Hi, I'm Matthew Dickey from Softry. In this presentation we will discuss forest road costing tools. Forest roads are an essential part of forest harvest operations. Their location and construction have significant impact on harvest efficiency, environmental impact, and operational costs. And oftentimes road costs are the most expensive part of harvesting timber. That's reasonable. I don't think anyone will disagree that owning and operating equipment is expensive, and the costs incurred by a road builder are passed on to the project owner. You may use a variety of different costing models to estimate road costs, but what really drives road construction costs are equipment costs, equipment productivity, and earthworks quantities and movement. In many costing models, the road construction costs may not be evaluated in terms of excavated volume, fill volume, and material movement, but these models are a means to simplify what can be a quite complex, tedious, and time-consuming activity. So we'll discuss common traditional costing methods. From least to most accurate, common methods include folks that don't cost the roads. So with this group, road costs usually make up a small portion of their total costs. Their margin is so good they don't worry about it, or they don't know where to start to apply another method to come up with reasonable numbers. Then there's those who guess. So no analytical method, but just come up with a number based on previous projects and a gut feeling. Slightly more accurate still are those that apply a flat rate to build roads based on their length. So dollars per linear meter or dollars per linear foot. Then slightly better still are those that apply a dollar per unit length, but instead of a flat rate, they use construction categories. So they delineate their roads into which category best represents that section and apply a different dollars per linear meter or dollars per linear foot rate depending on the category it falls into. The benefit of these methods are they are quick and fairly easy to estimate costs. Their downfall is it doesn't account for details that can have a large impact on those costs. So the final traditional costing method is costing based on unit rates for volume and movement. I'm going to refer to this as an engineer's cost estimate, or ECE. I'm sure it's referred to as in other terms depending on your location or your field. But we'll call it an ECE for the rest of this presentation. We recently conducted a survey. Only about 20% of companies used volumes and unit costs to develop their road cost estimates. That's likely due to the effort that's required using traditional workflows. Folks that do ECEs look at it through the lens of how much material should I excavate, place, shape, and compact? When they do that, they will usually consider different types of materials separately. So obviously building a road on a gravel esker is cheaper than drilling and blasting through solid rock. This is accounted for by quantifying those different materials separately using ground types. For movement, when they evaluate their movement, they will look at it under the lens of I need fill material here, where is that coming from? The other aspect of the problem is the unit rates. So excavation and embankment costs are usually dollars per volume, and different ground types have different rates assigned to them. Movement will be dollars per volume distance and dollars per volume. So dollars per volume distance accounts for the actual movement. Dollars per volume will be an additional cost to account for loading. So if you have to load material into a truck to move it at the location that cut material is being used as fill or spoiled, an additional loading cost is tagged onto that. Usually movement costs are categorized depending on how far material needs to be moved. Does it make sense to move it with a hoe, a dozer, or load it in a truck and haul it? These categories are represented by freehaul, overhaul, and end haul. This method usually uses volume estimates from a design, movement estimates that are based off the mass haul diagram but populated by hand, and an elaborate Excel spreadsheet. It gives you good numbers but is complicated and time consuming. So the arithmetic itself is not complicated, but you're considering a lot of detail and it becomes a big data problem. There are a lot of simple calculations, it is difficult to organize it, and it's difficult to keep up to date. So this method obviously relies on unit rates. If you're lucky, you may be able to call up your builders and get unit rates from them. If not, they will probably be willing to give you hourly rates and maybe even productivity expectations. If not, it's not the end of the world. It's pretty easy to find hourly rates. Some areas even publish average bid rates by machine for government contracts. Productivities can be a bit more intimidating, but they don't have to be. So with a bit of construction knowledge and or the use of reference material, you can produce reasonable expectations. An example of one of those resources is the CAT Performance Handbook. It is used by estimators all over the world, and it includes values and recommended adjustment factors to adjust production values to match expectations for actual conditions. Of course, the Caterpillar name is synonymous with construction. With that credibility, I'm going to borrow the opening line of the handbook. Machine performance must ultimately be measured in unit costs of material move, a measure that includes both production and costs. So CAT says that we must be on the right track considering the problem this way. Way back in 1983, the need was identified for a better way to cost roads. So roads cost a lot, we need better accuracy, and we need to be able to do this faster. That need wasn't addressed for quite some time, but here we are with a better solution. So we've improved on the ECE methodology. You still need to come up with your unit costs or use default settings, but we've put the ability to assign movement and unit costs to different materials in the design software. And since it's in the design software, we've streamlined the process and limit the opportunity for input error, and it keeps things dynamic. As you change your design, you can update your costs at the click of a button. This is also great for comparing different design options. So the user creates ground types and assigns unit rates for them. They assign their ground types where they expect to encounter them along the length of the road. They click recost, and a cost is reported. Now the other aspect we've improved on relates to material movement. So a typical mass haul diagram is limited in its ability to track movement. So using traditional methods, complexity is either ignored, approximated, or you spend an enormous amount of time trying to extract details by hand that are not tracked automatically. The complexities a traditional mass haul diagram doesn't account for are accounting for multiple materials. So if you have different materials with different expansion factors, the mass haul diagram will group those together and approximate it. The mass haul diagram doesn't account for materials moving in multiple directions at the same location. So here in the mass haul diagram, we can see that it's showing material either moving one way or another. Mass haul diagram doesn't account for side casting material and doesn't automatically account for where you should haul spoil material to. The mass haul diagram doesn't account for material quality requirements. So if you need a material with specific parameters at a given location, it's not going to look at where it should source that material from. There's very little smarts in it. And then lastly, the mass haul diagram doesn't account for the cheapest location to borrow material from. So we've created our OptiHaul technology to account for these considerations. Now this is something that can go underappreciated if you haven't given a lot of thought to the problem, but it's not a simple problem. In fact, to solve the best way to account for these considerations, you need to consider all the possible solutions. To accomplish that, OptiHaul is a mixed integer linear programming model that will solve for the cheapest material movement schedule. So what are the benefits of this approach? You get a better understanding of what drives the cost of your projects. You get to better evaluate the risk and feasibility of your projects, or do so faster with fewer errors. You get to incorporate costs when making design decisions. And since we've taken this design process and costing process and made it really quantifiable. It's allowed us to develop an optimization add-on for the software that turns the design process into a semi-automated one. So you can use our optimal software, put in your constraints, and it'll take into account all your costing information and generate a vertical alignment that's the cheapest solution. Ultimately, this results in reduced road costs regardless of how you're paying your builders. So, pay structures. Paying based on volumes of movement is even less common than using it for estimating. Only about 9% of their road building contracts are tied to unit costs and volumes. Now, I'm a big fan of paying based on volumes of movement. It's fair. You pay for work done, no more, no less. In the past, it's been difficult to get as-built data, but there have been advances in topo data collection that make this a smaller challenge now. Now, hourly is similar to paying for volumes, but the main drawback with this is if you have an unmotivated or incompetent crew, that problem can become a project owner problem instead of a contractor problem. Paying lump sum or incorporating the road costs in the agreed stumpage rate takes some of the financial risk away from the project owner, but they usually pay a premium for that convenience, and how the costs are broken down is usually opaque, making it difficult for the owner to negotiate those rates. And paying by length, so categorized or not, lacks details that have significant impact on how much effort was required. Here we have an example of that. Both segments are about 360 meters long on fairly gentle terrain. Using a flat rate or construction category system, these would be identical. But there's a difference of about 300 cubic meters, which is about 30 truckloads of material, on a short piece of road on identical ground. It might be the same cost for you, but it's not for your builder. If paying based on volumes of movement or hourly, the benefits of using our costing method are obvious. If paying per length, so flat rate or categorized, knowing what your builder is actually up against puts you in a better position to design roads that are cheaper, and puts you in a better position to negotiate cheaper per length rates. The same benefit carries forward when negotiating lump sum contracts or stumpage rates. Ultimately, better planning decisions, you're more informed. Being more informed is a great tool to have when you're negotiating rates. Circling back on the mention of technology improvements regarding quantifying as-built volumes. So this is one project one of our clients at Aratu Forest Limited sent us. The road was designed with conventional LiDAR topo data. After construction, they flew it with a drone. The imagery from the drone was processed in a photogrammetry software to generate an as-built surface area, and the two surfaces were compared for payment. So this is becoming more popular, and between LiDAR data and drone data, those are the two biggest advances that are driving this becoming more popular. So we've discussed different costing and pay models. We've talked about how we account for it, and we've talked about why it's beneficial to do it that way. The last thing I want to touch on is the direction we are exploring for future development. So one of the things we're looking into incorporating in the future is network optimization and costing. So rather than just looking at material movement along the length of a single road, sharing that movement across to multiple roads in a network. We'd also like to incorporate road user costs and fuel consumption over the life of a road, rather than just looking at it from a construction standpoint. We'd like to account for the costs required to mobilize special equipment to site. So an example would be if you expect to encounter a little bit of rock, well, accounting for having to mobilize that drill to site and including that in the costing equation. And being able to assign costs and ground type information by polygon rather than by station range. Thank you for your time, and if you have any questions, feel free to reach out to me. Thank you for your time. If you have any questions, feel free to reach out to me at the email provided on your screen. Thanks.